Okay, my name is Jakub Sorocki. I'm from the AJ University of Science and Technology, and in this work we explore the recently developed highly integrated stack-up where we integrate air-filled waveguide with printed circuit boards, so you could have active circuitry integrated with low-loss passive circuitry. For the assembly of such stack-up, at first we use screws to provide low resistant contact between two mating metal surfaces. So the first is the shared ground plane on the printed circuit board, and on the other hand we have metallization on the additively fabricated waveguide part. So in this work we tested two different kinds of snap fit joints which can be integrated in the printed part to see whether they can provide similar performance in terms of clamping force, which leads to low contact resistance, which at the end translates into total power losses. And our findings are that ball snap fit joint is quite well suited for such an application because of, first of all, it uses the round hole which can be easily, precisely and accurately drilled in the printed circuit board. And on the other hand, the clamping force is provided around its entire circumference, so that it's even in the ball area. And then if you provide tight enough pitch, then the total power losses are comparable, while the assembly process is much easier and faster and more reliable, so that the technology can be further applied for realization of, for example, active circuitry on printed circuit boards with extra narrowband filters or high Q elements, or antenna systems which are additively fabricated and snap on the printed circuit boards. Okay, thank you.